Welcome to another important lesson in our series, Chemistry Explained. We are in part 6, and today we are looking at the structure of an atom. And we are going to also look at the subatomic particles in an atom, the atomic number and the number of isotopes. In our previous lesson in part 2 and part 4, we have learned about matter and the elements and what they are made up of, that they are made up of tiny particles called atoms. Atoms may be tiny, but understanding them is key to unlocking the secrets of chemistry. First of all, let's define an atom. What is an atom? An atom is the smallest unit or part of an element that retains its chemical properties. That means an atom can exist on itself. Three subatomic particles that are well defined: the protons, the electrons, and the neutrons. Protons are positively charged subatomic particles found in the nucleus. Protons determine the elements. Electrons are negatively charged and they orbit, they revolve around the nucleus. They are responsible for chemical reactions. What's the meaning of that? Chemical reactions involve the gain and receiving of electrons. We have the third subatomic particle called neutrons. Neutrons are neutral particles without charge. They also coexist in the nucleus with the protons. We have atomic number, mass number, and isotopes. What do they mean? Atomic number with the symbol Z or Z is the number of protons in an atom. The number of protons defines an element. We will explain that later. Example, carbon has 6 protons. So its atomic number is 6. Mass number, what's the meaning? With the symbol A is the total number of protons and neutrons in the nucleus of an atom. Example, oxygen has 8 protons and 8 neutrons. It has a mass number of 16. The formula is mass number A equal to number of protons Z plus number of neutrons N. Isotopes. Isotopes are atoms of the same element with the same number of protons, but with different numbers of neutrons. Example, typical example is carbon-12 and carbon-14. Both of them have 6 protons, but different neutrons. What of hydrogen isotopes? We have hydrogen-1 called protium, we have hydrogen-2 called deuterium, we have hydrogen-3 called tritium. They are different, but they have the same number of protons. Protium, 1 proton. Deuterium, 1 proton, 1 neutron. Tritium, 1 proton, and then 2 neutrons. It's the same element, but with different mass numbers. So there's a relationship between atomic number, mass number, and neutron. The number of neutrons in an atom can be calculated using the formula N equals to A minus Z, where N is the number of neutrons, A is the mass number, that's the total number of protons and neutrons, while Z is the atomic number, the number of protons. Example, if you want to calculate the number of neutrons in oxygen 16, the number of protons is 8, the mass number is 16, and the number of neutrons is 16 minus 8. That gives you 8. Then carbon-14, the atomic number is 6, the mass number is 14. When you subtract 6 from 14, you get 8. That's the number of neutrons. So this is the simple way to calculate the number of neutrons. And I said earlier on that protons determine the element. What's the meaning of that? It means that the number of protons in an atom's nucleus uniquely identifies that element. Why? Every element on the periodic table has a specific atomic number, which is the number of the protons of the atom of that element. If you change the number of the protons, you change the element. If you see a brief table of periodic table, you see that hydrogen occupies number 1, helium occupies number 2, and other elements also. Carbon occupies number 6, oxygen occupies number 8, neon number 10, magnesium number 12. So every element has a unique position in the periodic table. Carbon always has 6 protons. If an atom has 6 protons, it must be carbon, no other element. Oxygen always has 8 protons. If an atom has 8 protons, it must be oxygen. If you take away or add a proton, the atom becomes a different element. Now, let's see what happens if we change the number of neutrons, the number of electrons, and the number of protons. What happens? If we change the number of neutrons of an element, the element stays the same, but becomes an isotope. Example, carbon-12 and carbon-14. Carbon-12 has 6 protons and 6 neutrons, but carbon-14 has 6 protons and 8 neutrons. It's the same element, but they are now isotopes. If you change the number of electrons, an element stays the same, it's the same element, but it becomes a charged atom. Example, when sodium loses an electron, it becomes sodium ion. That means it has lost an electron. It's now sodium ion, it's still sodium. Any electronegative element like oxygen, we normally refer as example, gains an electron, it becomes a negatively charged ion, but it's still oxygen. But what happens when there is a change of proton? The element completely changes. Example, nitrogen with 8 protons will no longer be nitrogen. It will become oxygen. Also, sodium, instead of having 11 protons, if it has 12 protons, it will become magnesium. So these are very important facts we need to know, that proton determines the atom. Today we have learned that atoms are made up of protons, neutrons, and electrons. The atomic number identifies an element. The mass number is a sum of protons and neutrons in an atom. And that isotopes are atoms of the same element with different neutron counts. I hope you have gained something. Like, subscribe, and comment with your questions. Thank you.